Hi again. Here it's as we discussed before regarding the conceptual model when it comes to building a model for a business case. And the business case that I started with you last in the class or in the last lecture that I uploaded on LMS. This was the model as before we talked before. So if you don't know how we reach that, you have to go back to the presentation that I added my explanation with some text. This is the model, and as we know, the y and x and z. Y is the dependent variable, x are the independent variables, and z are the segmentation variables, or we call them moderating variables. Now I want to show you this data. We stopped at this data will be turned into questionnaire or survey, and we need to imagine at this situation that we distributed a kind of a survey to ask our customer to rate their perception or experience throughout their purchasing behavior when they order something from our site. Later I'm gonna show you the data that we pretend that we got them. You can see here in the sheet of Excel, because I'm in Excel environment now, the data set here. So we'll show you later. But let me go ahead and tell you what we need to do. But in this sheet, I will upload it. As you can see, I'm going to upload it as well as an Excel file, not only as a video, because I want you really to play a little bit with the data set here. So these variables that you can see here, they are explained in the sheet. In this sheet, you can see here the different names of the variables in our conceptual model. So I might really increase it a little bit in terms of I'm trying to make it bigger for you. Let me see. Yeah. Okay. So now this is the customer type, gender, age group, location, and payment. We have other variables as X, like product quality, online tracking system, and so on and so forth, until all independent variables. And from these variables, I selected only X19 as the Y variable. Now, before really making any analysis, you need to understand how this data being coded, because if we go to the data set here, you're gonna find the very rectangle standard form of the data. The first column includes the ID of the customers. If I go down here, double click here, I'm gonna go at the bottom of the data set. We have 100 customers. We interviewed them, or we sent them the survey, and we selected, we recorded all variables in the model, x1, x2, and x3, and so forth. So remember this x1, x2, and x3, and x4, and 5, we choose them to be z, so I'm gonna color them like green, just for you to differentiate between the moderating variables like z. We can even call them, just for you to understand, this is z1, and this is z2, and here it's z3, and so on, z4. So I'm gonna keep the x6, x7 as they are, because we keep them x. I could really change them to x1, 2, 3, but you will get confused because the variables in these columns are explained here by original number here, like x1, x2, x3. So maybe you can make this also z1, z2 in order to make your life easier. Z2, and here z3, Z4 and Z5. So every time you want to know what's the meaning of each Z, you come back to the sheet called variables. You see the name. If you want to know how each variable was measured, you go down a little bit. You will find here that X1, which is in this case Z1, is being measured based on as a customer type. And we have here customer type. Let me make the color a little bit more better than that. Let me take maybe something dark blue. If the customer coded by 1, it means the customer spent with us less than 1 year. If coded by 2, then the customer spent with us between 1 and 5 years. While 3, it means longer than 3 years. So basically, you can do that. As for gender, which is in this case Z2, is being coded like 0 and 1, 0 for females and 1 for males. As for the age group, which is in this case Z3, 0 it means customer who are younger than 30 years old, and 1 it means customer who are older than 3 years old. As for Z4, in this case, 0 it means the customer was local customer in Canada, for instance, or 1 it's an outside the country. As for the last moderating variable, Z5, the people pay in cash or pay in credit card, as you are seeing here. As for the rest of the variable here, you can see from X6 up to X18, because those are our X's. And now we have the last one, which is the X19. I would call it Y in this case, because it's the dependent variable. I'm going to color it by maybe orange color to make distinction now. So now this is our framework, the Z variable, the X variable, and the Y variable. If you want to know how these variables are being or were measured, I go back to variables, and you can see here each variable from X6 up to X18 being measured from 0 to 10, and you can read it here. You can find out that they are being measured in a decimal points as well. As for X19, which is the Y in this case, let me put here Y just to make your life easier when you come back to this sheet, is the customer satisfaction. We are not really working with that in this moment for the time being, until we come later to that. So let me maybe I can make this colorful, yeah, well, like that, and maybe this is blue in order to show you that they are really related to the blue color, maybe something like that, and this were the green one. So maybe make it like this. Okay. So now you have the variables, and we need to make some analysis based on our data. If we come here, but the question is what we're going to do with this data, how we start, and so on. So the best way is always start with X19. But before going to the analysis, I want to go back to the slides here to explain some concepts. So I'm going to talk about in the next couple of minutes about the idea of population and sample, the labels and very important terminologies, which is the difference between parameters and statistics. In data analysis, we have two types, descriptive and inferential. And we knew from past lectures that when it comes to descriptive analysis, we have different types of ways different ways basically to look at our data, from central tendency, variation, shape, as well as location. In addition to that, we can look at our data from graphical representation. This is the classification of data analysis. I talked about that before. We have two types, descriptive and inferential. Descriptive, as you know, they are always answering questions in the past. Inferential, more or less asking questions outside the sample or in the future. We call them sometimes predictive. Here it's a very important slide which clarify the difference between population and sample. I always like to show you that the population is always hidden. It's like a wall here, and we are sitting here somewhere as human being or decision makers or analysts. So I wanted always to pretend or to imagine that we are always trying to figure out what's behind the wall, and because it's always hidden, we don't know, we are guessing. In order to have the best guess, we try to collect data. So once we get data through sampling techniques, as I discussed before, then we get a data set, like the data set here in this sheet. Then we're going to do some analysis. But when we do some analysis, as you know, in this class, we're going to focus only on descriptive analysis. So the value that we're going to get, it will be values that describe the sample, and we call them statistics. X bar is a number, it's like a value or symbol for the average of the sample. And you can see mu here is this little yellowish symbol. It's called mu. It's a Greek letter, and the old textbook talking about the descriptive analysis, they always use mu for average or the mean of the population. But the mean of the sample, we call it X bar. Whether we are, and the sigma square here is the variance, the pi here is the proportion, X bar is the average of the sample, S square is the variance of the sample, P is the proportion of the sample, maybe proportion of how many females and how many males out of the total sample, or how many younger people, how many older customer, and so on. So we can see here for parameters, we name them in Greek letters, but when it comes to statistics, we use like the usual English Latin symbols. So you have to pay attention to that because it's very important, because the way we write our measures, like mean or median or variance, will indicate immediately whether we are talking about parameters, or we are talking about sample, are we talking about population, or actually the sample itself. So the characteristics of the population, we call them parameters. So population has parameters, but the characteristic of sample, we call them statistics, and sample has statistics. So if population has parameters like mu, the average, the mean, I mean, the variance and more, like the pi, the sample also has characteristics. In this case, we call them statistics. So statistics are estimation of the parameters. So that means everything we do when we get the data set, that means we get sample. So everything we calculate will be called statistics and not parameters. But we always hope, as you can see here, that hope that our X bar is basically very close to the mu, or the other way around, because we are trying to find out the mu, because when we make decision about the population, so we need to know the mu. But since we know that we will never be able to access the population, then it's very clear that we're going to live only with the X bar, or the average of the sample. But this is not the end of the story, because once we get the average of the sample, we need really to help the decision makers to tell them something about the mu. We cannot really say mu equal X bar, but mu will be around the X bar. So X bar basically is a way to find a location where maybe the true value, which is the mean of the population, is around. And I'm going to show you this. Another point I want to remind you about is that data types. We have two types of data, categorical and numerical. On the categorical level, we have two scales, nominal and ordinal. On numerical type, we have interval and ratio, and we talked about that before. We need to go now to our data set and our variables to check which one is categorical, which one is numerical, and which one is nominal, and so on. If you watch here the Z here, Z customer type, gender, age, and location, and payment method, all of them, they are categorical data, because you can see here they are categories. If you want to know why I call them categorical data, simply go down here and see how they are being measured. The way they are measured here, they are categories. Okay. The thing is, if you look at Z1, it has three levels. We call them levels, or in this case categories, but we call them levels: level 1, level 2, level 3. You can see here level 1, level 2, level 3, they have to be in order. So this is an ordinal data. So we might really say here it's ordinal, categorical, ordinal. Ordinal, because the data are ordered here. So let me make it here green. As for gender, it's basically because it has only two, then when we order them, it doesn't matter to write male first or female first. So this is very clear. It's categorical, but we call them nominal. The same is for age group, because age group you can write younger before older or the other way around. The same for location, because you can order outsider before local, doesn't matter, and credit card the same. So all of these are basically, this is the way. So as for the rest here, from 6 to 18 and including 19, they all are numerical. And interval, why interval? If you remember, interval, it means 0 makes sense. So can anyone give 0 and it makes sense? Yes. Someone is not very happy with the product quality, they are allowed to give 0, and 0 it means very poor here, very poor satisfaction, or very poor quality. So I'm gonna color this as blue again, and to be honest, all of them are the same, so I'm gonna put it like that for you later on. Oh, I missed one. And the same for the y, because y is also measured over the scale, or on the same scale. So now we finish with the type of data, and now we know how we do that. Last one, which is basically, I have definitely shared it with you in different lectures, but in different colors probably. So here it's the way we present our data and so on. Now I want to show you how we calculate all of these things and draw histogram plus box plots, and it will be enough for today. Let me go ahead to the data set, and since I'm not going to start with each one here separately, I want to start with the X19 first, and then I will come to show you how we analyze the Z1 and so on. Remember, those are categorical and those are basically numerical interval. Z1 is categorical but ordinal. As for Z2 up Z5, they are categorical but nominal. So let me take only one variable here, because when it comes to categorical data like this, you can't really calculate average or standard deviation and so on, because it doesn't make any sense. The only way to calculate, to make sense out of this data analysis for any categorical data, is to calculate you count. So let me take this variable in another sheet, put it here. So I just copy and paste it just to make it clear for you. Okay, and let me try to make it bigger a little bit in order to see clearly on the screen. So now we want really to count how many 2s, how many 3s, and how many 1s, because we have only 3. There are multiple ways to do that. I'm going to share with you one of them. So I'm going to write here customer type, as you can see here, customer type. So, and I know they are 1, 2, 3, so I can write them easily here. I will make some formatting here to make it a little bit more prettier. So this is basically Z1. Let me make it like that. Now I want to count, because it's the only way to analyze my data categorical is to count. So I'm gonna get the count here somehow, and I need here to populate it using different ways to count how many ones, how many twos, and how many threes. And then we can do a lot of things about this value. So there are different things here. You can really use the count function, countIf function, in fact. Then it asks you here, what's the range that you want to count from? So we want this range, right? So I'm gonna write from A2 here until A101, because I know my data is located between row number 2 and row number 100. Then it asks me what's criteria you want. I'm asking Excel, look Excel, try to find in this range the one and count how many ones. So I'm gonna really just locate the criteria by selecting the value that I want to count. Then I close the bracket and then enter. So I get 32 people. I can repeat the same thing, so I can take it, copy here and here, paste it here, and I paste it as well here. But I paste it here, but it's the same D2, right? So I need to change the D2 here, make it D3. So I remove this here, enter. So we have 35 people from customer type 2. And here I have to change this to D3. I can write it by hand. Sorry, D4 in this case, sorry, D4. So I have to make sure that the sum equal 100. So I'm gonna sum this and I get 100 because my sample size is 100. So this is the total. So it's basically, I have very good, or at least I know that it's my data being correctly counted. So now I have this. There are two methods to draw that. I can select them like this, and then I go to insert. And in this case, I'm gonna go to one of the interesting column chart here. I'm gonna use column chart because my customer type are 1 to 3 and they are time based. So it's better to do it vertical and not like this one, horizontal, because horizontal it's only valid if you, as we discussed before, if your data is not based on time. But since our data is based on time, and usually we go from left to right, and 1 it means customer who spend less than 1 year, 2 it means people spend more than 1 and 5 I mean, and 3 it means more. So it's very interesting to use this. So this is one way to do it like this. If you want to do it vertical, horizontal, you can just I will not really do anything formatting here because it will take some time, but I'm gonna double it, and after I double it, I'm gonna change the type of while I am selecting the chart. You can see here from the chart design bucket here, you can see here change chart type, or right click on the same curve, you get also change chart type. So you can take it from the ribbon or from here. So then I can go ahead here on the left hand side to choose the bar chart, and then I get another bar chart here. So I'm gonna get this one. Yeah, this is not bad as well. This is another one. It's up to you which one to use. So I'm not really concerned right now by the formatting. Last representation for this data, I can take it again, Control D. In this case, why not to make it a pie chart? So I'm gonna scroll a little bit here, and again I'm gonna right click on it and then change type, then I choose the pie, and then I choose the pie here. So now the pie is very clear here, but I can add legend here because here I don't know which one is blue, which one is this. So I'm gonna click on the plus here, and in plus I'll find legend, and the legend are here. So this customer type 1, 2, 3. If you want to add some labels in the pie, because sometimes it's interesting, so I right click on this arrow and I check the box, I get values here. This value, if I again click on the arrow, it could be, I can put it outside, I could put it inside, I could put it in the center, and so on, or even in that form, like data call out. Data call out always, it looks like it gives you basically interesting values in percentage as well. So it's up to you how to present your data, but this is how we presented our data. You can replicate the same concept for each variable. So I'm gonna rename this sheet by calling it Z1 analysis, and basically the only analysis is to draw it. And this is just, let me rename it to slides, just for you. When you get this sheet later on, you will get everything named correctly and properly. Now, since our data, this is one of the things, I can also make another, when you get this sheet, because I'm going to upload this sheet on LMS, you will see the function already written here. So you can come here and check the function. But I can do it another time. I will write count, and here count again, just like that. And then in this case, I will not use countIf function. I'm gonna use another function. But here I have to do several steps. First step is to select the data here. You see, you have to watch very carefully what I'm doing here. I select it first, and then after I select it, I write the function equal frequency. I push the tab to get the whole number. So the data type, the data array is A2 again to A101. So I have all my data, and comma, it asks me what's the bins array. Bins array happens to be this one, 1, 2, 3. So I'm gonna select 1, 2, 3, and then close the bracket. And now it's another step, very, very critical. I'm going to don't press enter. Don't press enter. I repeat it again, don't press enter. Before pressing enter, you have to press Control Shift. Now I press Control Shift and then enter now. So I'm gonna write it here. First step, select from cells from F2 to F100, sorry, not 104. Okay, let me make it without anything. Step 2, write the function, the frequency function, or function by, okay, write the frequency function by entering this, this form. You write equal and then frequency, and then you write A2 to A101, and then you put the bins, which from D2 to D3, 4, sorry, and then now control, then press Control plus Shift plus enter together, okay, and then enter. So this is how you do it in order to get this number like that. Otherwise you will not get the same number. So we'll get the same number. Now number 3, I might really do select data bars from condition formatting. Like this. Look, what I'm gonna do here, I'm select this and go here condition format, and then data bars, I select any color. So let us select any color here, yeah, anyone. Let's take this one, or even this one. Okay, so you have, this is more or less similar to that, but in different format. Okay, so now we finish with this. So let me save it, and we go ahead and take another one, but not in this case one of the categorical, because you can always do it for categorical data. But what I'm going to do now is to take X19, control copy, I take it in another sheet, new sheet, and I'm gonna call it x19, in this case y analysis. So I'm going to do some analysis for this variable. So now this variable is important for us because this is the customer satisfaction. In our case, it should be something related to online learning experience when we get our data. So basically I have this data. There are multiple ways to make analysis here. As you know, I want exactly to show you, if I go to these slides, I want to show you how to get, I want to now draw a histogram, I want to draw the box plot because it's only one dimension, which in this case one variable. But also I want to calculate the mean, the median, the mode, the variance, the standard deviation, the range, the coefficient of variation. I want to show the skewness, the kurtosis, and I will show you later on the quartile and so on, and the z-score later on. Now let's go back to our variable here. Let me make it the color orange, and this make it color green to fix our standard here. Anyway, I'm going to come here. There is, I showed you sometime in Excel when I go to data bucket here or in the tab. If you go to the very right of the screen or the ribbon, you will find data analysis. So I hope you know how to get data analysis. If you don't know how to get data analysis, please let me know so I can upload a short video about how to get data analysis. So I'm going to get data analysis by selecting data analysis. Data analysis will give me multiple built-in functions that's very useful when we do some analysis. Basically, most of what we're going to do in this semester is to use descriptive statistics, and then I push OK. Excel asks me here, what's your input range? And I have my data from A1 to A101. Why it's 101? Because my data will end at this row. But I have to tell Excel that row 1 has labels. So I'm gonna check this box. Very important, because if you don't check this box and you have selected A1, Excel will result or will provide an error. I want the result to be in this sheet, but before that I'm going to select summary statistics and confidence interval for the mean. Remember, confidence level for the mean, and it's the default here 95%. I'm going to leave it like 95% now, like that, but I will tell you the story behind it. So it looks like we are okay. I selected the data here, I checked the label, I selected the summary statistics to be the output as well as the confidence, but I have to tell Excel either the output to be in a new sheet or in the same sheet. I wanted to come here to the same sheet, so I'm gonna select this radio button called output range, but I have to tell Excel where to start to put the data. So I'm gonna write here starting, let us say, go back here a little bit F, and then I push OK. So basically we are now done with all options that we need. We don't need anything else. So whenever you want to do the same thing, make sure that you selected exactly what I did here. So I'm gonna push OK, and then Excel will be very generous to calculate a lot of things here for us. You can see most of what I showed you before in these slides, like median, standard deviation, skewness, and kurtosis, are basically here. Mean, median, mode, standard deviation, variance, kurtosis, skewness, range, minimum, maximum, total, and so on. Let us do a little bit of interesting work here. What I'm going to do is basically to show you some of an interesting things here you can see here, if I go to each cell here, you find values only, so you don't know how Excel calculated it. So but Excel used a built-in function for each one, so I'm gonna write them here for you. Let me write here formula, and here the formula as well. built-in function or the function. Here how the formula is being written, just to see it how I wrote it here. So the mean, there is a function called average, and the average now I can take from A2, not A1, because otherwise it will create a problem. So I'm gonna add here A2 to A101 and close the bracket, and just all what I need to do is enter. I get the same number. So there is an interesting formula text function. You don't need to do it, it's just I'm doing it in front of you, because if you want to repeat after me, you know which function I wrote it here. So here you cannot see the function, right? Unless you look at the bar here, and very small, but I wrote it here again to make it easier for you. Let me make this a little bit different color to see what's going to happen here. I'm going to basically do a lot of function here. At the beginning it's not applicable because here it's empty, so I'm gonna write every now and then something here, and you're gonna see it what's going to happen. I'm gonna skip this for now, but the median, there is a function called median, and again from A2 to A101 and enter. You can see it here and the same number. Here it's called the mode, again A2 to A101, again it's 7.6. Standard deviation, there are standard dev function, but you can see here once I put the dot, we have P and S. P is for population if we have it, but we will not have it always. We have S for sample, so I'm going to use the S for sample because I have only sample. I'm going to put also my data here again with the same concept, so I get the same value. I can now do it again for variance by taking the variance like that, also using the S, and I get the data as well from A2 to A101. You can see similar values for sure. Kurtosis, there is a function called Kurt, and again A2 to A101. Skewness, there is functions called skew, and it's also A2 to A101. Range is basically the maximum, which I calculated here, minus the minimum, which I will calculate here again. So definitely it's 0 for now. But here I can write minimum function, it's called min, A2 to A101, enter. And now the max, the same thing, you can guess, the same thing. And this is, the sum is easy, it's the sum function in Excel, it's easy. Doesn't make any sense here to make the sum, but maybe if you get the sum and divided by sample size, you get the average. But does it really help us much here because we have the average? The sum makes sense if you have, for instance, money, you want to make total of money, or like sales or something. Count, it's basically there is a function called count. I use it like this. This one, it's basically, it's a little bit complicated, but let me write it here. And you remember this was for 95%. As I told you, we'll leave it like that as a default. But I'm gonna write function here, but I will explain to you in different video or in different lecture. So I'm gonna write here the function exactly. There's something called T function, and it's called the inv.t, and here the complement of 95% is 95% is 5%, and there is something called degree of freedom, which is this one minus 1, and I multiplied by this standard error, which is here. Standard error is in this case it's 0, but standard error, if you go here, standard error, how standard error is being calculated, it's basically we take the S, which is in this case standard deviation, divided by square root of the sample size, which is 100 here. Okay, so I enter here, you get really the same value here, and this value I took it and I multiplied here by this weird function. I will tell you later on stories about it, but not in this video. But again, here's how I got the same value here. Let me give some names here. This we call it X bar because it's a sample. This we call it standard error, and standard error is I divide S by square root of n. What is n? N is this one, which is the sample size. And yeah, the range is easy here. It's the max minus the min. Here it's we call it S because it's standard deviation. That's why I took S and square root n here, so I got the standard error. This is usually we call it S squared, or S like this, S squared. And those are some names. You will hear me saying them most of the time. X bar, I mean the sample. So all of these things are statistics. So I'm gonna write here statistics, because it's very important to know that they are not the parameters. They are not the parameters. All these things are statistics, all of them. So it's very important to know, and those are the values. Actually, I mean the values of statistics, so it's basically the same thing. Okay, so it looks like we are doing fine so far. And then, yeah, this is how we calculate them. We know the average and so on. Now I'm going to show you just how to calculate to get the histogram for this data. So basically I'm gonna do that. But before doing the histogram, let me tell you the something that's not here is called the mid-range. Let us write the mid-range. We didn't calculate it before, and mid-range equals basically the maximum minus in this case plus the minimum divided by 2. So our mid-range is 7.3, so it's something here. So if you want, you can control copy. If you want to see how it's calculated, is here, something like that. Another thing that's not here, it's the coefficient of variation, and we call it the CV. So, and you can, if you remember, I take the S divided by the average, and I multiply by 100, but I have to close the bracket here. So I get it as if in percentage. So this should be percentage. So I'm gonna really move it like that. So basically, so it's a 17%. Just to show you something like that. As I told you before, this coefficient of variation is very important when you compare two groups, compare stocks, and the more variation here percentage you have, that means there is more variation or more risk. Another point which is related to this part, let me call this part E for now, or error margin. We call it E for now. Let me make it bigger here for you to see what's going here. We call it E like that. So in order to know where is the true value, remember when I said the mu, where is the mu, the parameter? The question is, where is the mean of the population, which is, we call it mu in this case. Here it's the parameter. Where is it? That's the question, right? So based on the E value above, we can construct what we call it a confidence interval for the mean. In this case, we will have lower limit of the mean, of the population mean, which is basically the X bar minus E, and we're gonna get here the upper limit of the population mean equals X bar, the average, plus. So it's basically, we are saying that the mu, or the population mean, could be around the X bar. We don't know exactly where, but X bar is a point where we can search about or search for the true value around the x bar. So now you know if x bar is wrong, everything is wrong. For that reason, we need to be very careful when we select our data, and why we have to pay attention to the sampling, why we have to pay attention to the sampling techniques, sample size, and the questions we ask, the biased and the unbiased things, and so on. Why? Because we want to make sure that the x bar is the best x bar ever. So now I can take the x bar is up there, I can take it like that and minus the e, and I can take the x bar plus the e. So now I constructed the confidence interval. So I can say now we are 95%, we are 95% confident that the true mean of the population, in this case the parameter mu, may fall between 6.68 and 7.15. It's a very interesting result, I believe. This is for decision making is the most important thing. So the above statement is the most important result or conclusion where decision makers can take action. So the above statement is the most important conclusion where decision maker can really take actions or action. So it's very important to go and to understand what's happening here. And I wrote everything, as you can see here. You can come up here. Let me take the formula here for you. V and V. Let me make the formula different colors. This is different colors, if you like, just to see that there are formulas here, instead of really getting overwhelmed with many things I calculated here. So let me make another save here, just to make sure that everything will be there when I send you this file. So what's really needed now, it's basically only one single thing, is to draw a histogram. So insert, and you see here the bucket is called histogram, and then I select histogram. So histogram is very it's calculated here by Excel. Sometimes it's really not very helpful for Excel, because Excel is Excel decides on the bins, as you can see here, from 4.7 to 5.6. So I don't have much control unless I format it. So I don't like this one, but I might really do it differently. So I'm gonna leave it for you here, somewhere down here. But this is for let me write here equal. Oh no, it's this is another. This is histogram for X19, which is the customer satisfaction, which is the Y here, customer satisfactions. Hopefully sometime this semester we're gonna write here histogram for online learning experience at Algoma University in last semester, something like that. I'm gonna show you some other things where we can control the bins. As you can see here, the bins is 4.7. You will know why 4.7 if you go up here and you see the minimum value for our data is 4.7. So Excel decided to start from 4.7, and to be honest, it's makes sense, because anything else less than that will be 0, as I will show you later. But once you start from 4.7, I cannot really tell Excel now start from 5, because 4.7, I wanted to have decent numbers. So I might do that if I do it manually a little bit. So I'm gonna go a little bit to the right hand side here. And what I'm gonna do here, I'm gonna do the same thing as I did for Z1. I'm gonna write here bins, and the bins I'm gonna put 1 and 2 here, and I drag it down 1, 2 until I reach the 10 categories, because I know the scale is from 0 to 10. Again, I can take this color to format my, oops, I did a mistake here. I should have take this and then I move to the right and make it like that. So now I need the count. I'm gonna do the count the same thing. If you remember, now you can see it again. I'm gonna select them here first and then write equal frequency, and the data is in A2 to A101 and comma the bins, so I can take this value are the bins. And now I close the bracket. Remember, I to push the Control Shift first, and then after, while you are pushing Control Shift, now you can hit the Enter button. Then you get this value. Once again, I can take this value and I insert. In this case, you don't need to go to histogram because it's already calculated. Became frequency distribution. Then I go to bar chart here, or column. I take the column, and then I get the column here. So it's basically, this is another, you can call it also column or frequency distribution for x19, which is the y, without writing the rest. Of course, you want really to remove this maybe and to add some labels to have the numbers here. You can see here anything less than minimum value, which was 4.7 here, this one. Anything less than that will be 0, so it's a 0, as you can see. So the Excel wasn't wrong, but maybe I want to have the 1, 2, 3, 4 like that. You can change the width of the column, and I will not do it now because maybe it's too much for here. So this is one thing. But also you can, let me take it down here for you, but also you can take this and go to condition format and choose the trick of data bars and choose the color that you like. So let's take another color, different one, so it looks like the same but in in horizontal format. Anyways, I showed you multiple ways to draw it histogram using the chart of histogram. So we get to this by going to insert and select this histogram bucket, and then you select the data first, right? Second method that I showed you now is to build the frequency function by building first the bins, and then you select this area, you write the function frequency, and you show Excel where is the data and where is the bins, and then Control Shift and Enter, you get that. You can take the same data by inserting curve, like in this case column, not the histogram, or you go to condition format like this one and take the data bars option. Last thing before I close this video is to do the same thing with respect to Boxplot, and Boxplot is very useful, as you know from our last discussion. So I go here, and in this bucket of histogram you will find out that there is a Boxplot here. So Boxplot is, so I'm gonna really talk about Boxplot in a separate video, but just to show you that it's really interesting to see another visualization of our data. Let me take it beside here, and this is the Boxplot for the same variable. Definitely it's not really interesting to look at the Boxplot without comparison, but I'm going to show you comparison later on. So I think I'm gonna close this video. So this is all what I have in this video, and when we meet next time or we talk next time, I'm gonna show you more and more about that. So I hope it was useful